Introduction. In November 2026, Voyager 1 will reach a symbolic milestone. It will be 25.9 billion kilometers from Earth, so distant that light will take a full 24 hours to reach it. Launched in 1977 and now in interstellar space, this isn't a scientific breakthrough, but it marks just how far human-made technology has traveled, a quiet reminder of our reach into the cosmos. What it means to be one light day away. Voyager 1 reaching a distance of one light day means exactly that. It will be 25.9 billion kilometers from Earth, the distance that light covers in a full day. This will happen around November 15, 2026, based on data from NASA's Eyes on the Solar System simulation tool. Right now, signals to Voyager already take about 23 hours to arrive. By late 2026, that time will tick over to a full 24 hours. It's a small change, but it marks a symbolic line in Voyager's journey. After that, every message we send will arrive a day later and take another day to return. That's 48 hours just to complete one exchange. There's no event, no shock wave, no physical boundary in space that Voyager is crossing, but this milestone makes the vastness of space relatable in a way that scientific measurements often can't. Everyone knows what a 24-hour delay feels like. Now apply that to a conversation with a spacecraft, and you begin to see how distant Voyager is. Voyager was launched in 1977, intended initially to study Jupiter and Saturn. After completing its planetary mission, it continued outward. In 2012, it crossed the Heliopause, the boundary where the solar wind stops pushing against the interstellar medium, entering what scientists call interstellar space. Since then, it has continued on a slow, silent journey outward. It's currently about 166 astronomical units away from Earth, moving at roughly 61,000 kilometers per hour. Despite its speed, it takes years to gain even a few more AU of distance, and the light day mark has taken nearly 50 years to reach. This moment is not about destination but about reach, how far we've extended our presence beyond the Earth and what that tells us about time, motion, and endurance. Communication at the edge. One of the biggest consequences of Voyager's distance is communication delay. Even now, every message must travel nearly 24 hours one way. The signals are extremely weak, picked up by NASA's Deep Space Network, a global system of radio antennas designed to capture data from the farthest points in the solar system. As the spacecraft gets farther, these signals become fainter. It's not just about time, it's about energy. Voyager's transmitter runs on a slowly decaying radioisotope power source, and its signal is weaker than most household electronics. To manage this, NASA engineers have adapted. They send batched commands, pre-programming sequences to minimize the need for frequent interaction. There's no chance for immediate correction. Each adjustment must be planned days in advance, and the results might not be known for 48 hours or more. This situation highlights how future missions beyond Earth's orbit must be autonomous, with spacecraft making their own decisions based on internal diagnostics and preset goals. Voyager's hardware is over 45 years old, yet its systems are still operating, though not all of them. Over time, instruments have been shut down to conserve power. In 2025, the cosmic ray subsystem was powered down. In 2026, the low-energy charged particle instrument will likely follow. By the early 2030s, the spacecraft will no longer generate enough power to keep its transmitter running. At that point, contact will end. But even before that, the delay forces a different kind of thinking. We're no longer in a realm where human hands can steer the mission in real time. Instead, Voyager represents the model of what remote, long-term, hands-off exploration looks like, and that's becoming increasingly relevant. Missions to Europa, Titan, or even interstellar precursors will face similar or greater delays. Voyager's continued success under these conditions is not just impressive, it's instructive. What happens after the milestone? Once Voyager 1 passes the light day mark, it will keep going. There's no final destination, just velocity and momentum. Its trajectory points it toward the outer reaches of the Oort cloud, a distant shell of icy bodies that may encircle the solar system. If it does reach that region, it will take thousands of years to get there. And even that isn't the edge. According to some definitions, the true boundary of the solar system is where the Sun's gravitational pull becomes negligible, roughly 2 light-years from Earth. Voyager would need another 1.9 light-years, and at its current speed, it would take nearly 40,000 years to reach that point. We won't be around to see that, but Voyager 1 will keep drifting for millions of years, barring collision or capture. It carries the golden record, a time capsule with images, music, and greetings from Earth, a message for any intelligence that may one day intercept it. Meanwhile, there are no active missions set to overtake Voyager's distance. New Horizons is still traveling, but it's decades behind. Future deep space efforts, like Breakthrough Starshot, propose tiny laser-driven craft that could reach nearby stars in a few decades. These remain experimental. But Voyager remains a benchmark, not because it's fast, powerful, or high-tech, but because it endured. Its journey offers lessons in mission design, patience, and redundancy. It reminds us that reaching deep space doesn't always require speed, sometimes it just takes time and resilience. The light day milestone marks a point of no return, not physically, but in terms of operational feasibility. We've now sent something so far that even light takes a full day to reach it. That's more than distance, it's a shift in how we think about our place in space. Outro. Voyager 1 reaching 1 light day from Earth isn't a breakthrough, it's a quiet milestone. A reminder that with patience and vision, even slow journeys can go unimaginably far. Not a headline, but a lasting legacy.